Evening. I'm Spot On Weather meteorologist Matthew Euler. Welcome to tonight's video. This one's called Release the Arctic Hounds. And cute little puppy here to start tonight's video presentation. Look at this little doggy. He's all bundled up. You know, the owner put him in a nice little coat here to keep him warm. So, you know what? This is something we're going to have to take into account if you're a dog owner and you're going to be taking your dogs out for walks here in the basically around Christmas time period, looking very, very cold. And I'm going to delve right into the charts right here. And let's get right into the discussion. All right, so first things first. Due to time constraints, I'm only showing the GFS Ensemble forecasting system for tonight's charts. Now, I have looked at the European Ensemble prediction system charts as well, and things match up fairly well with these charts overall as far as positioning and expectations of the cold air that's going to be coming east over time. But right now, what I'm doing on each of these slides, I'm just going to cover a specific day, and I'll start off here on the left with the morning, a morning looking chart, and then on the right here will be the afternoon chart on the right of each of these slides. So morning on the left, afternoon on the right. This is the GFS Ensemble forecasting system. It's been a very consistent ensemble forecasting system as far as projection of this pattern change coming up for the eastern U.S. The last few days it's been pretty much showing exactly what I'm showing you right now. All right, so let's take a look at some of the key features this Saturday, the 17th of December, up at 500 millibars, which is 18,000 feet above the ground where we live. All right, first things first, let's just brief these west to east. The brown coloring here indicating ridging. Underneath a ridge, you typically have sinking air motion, dry weather, and milder temperatures. Now look what's happening here. By this Saturday, we're seeing a major high amplitude ridge move northward or extend northward into parts of western Alaska, the Bering Sea, and the Arctic Ocean. As this thing builds, the heights build here into Alaska. Typically what you have is a downstream trough. The higher this builds out here over Alaska, the ridge, the deeper the trough is downstream. So by Saturday morning, the 17th of December, this upcoming Saturday, you see the green coloring indicating troughs. Troughs are basically associated with unsettled weather as well as much colder temperatures. So we see green coloring here. That's the troughs. The purple's also troughs. The blue's also troughs. But in general, we got a closed low situated over the Great Lakes by this Saturday morning. We got a trough axis extending southwest across the Midwestern and central U.S. We have colder temperatures and lowering heights, generally all the way to the East Coast by this point, as colder air is working its way into the area. Please disregard the writing here at the bottom too. This is from older slides, so just wanted to point that out. We're not actually seeing the weak ridging here in this case. I really focus on updating the slides today. So just pay attention to the slides that I'm showing you. Now the graphic here on the right, look what happens to the trough. By the time we get to Saturday afternoon, it progresses further to the east. See the green coloring here, generally from the eastern Nebraska, eastern Kansas, eastern Oklahoma area, all the way to the East Coast. We have exceptionally below normal heights. Those below normal heights are associated with colder temperatures. Look at what's happening with this upper level ridge. It continues to push northward. We also have the feature here that I didn't mention on the left side here for Saturday morning, this negative NAO situation, a west-based negative NAO, where your higher heights are generally situated to the west of Greenland. So a blocking feature over the top here. What storms like to do normally in the U.S. is they like to make that inland turn from southwest to northeast. They make the inland cutter type storm track, whether it's across the Midwest from southwest to northeast or across the Appalachians. But with this block over here, positioned at this location, those low pressure systems aren't going to be readily able to just move northeast like they normally would because it's blocking that higher heights. So these are the main features you're seeing for this Saturday, the 17th of December. Look at the green coloring here. By Monday, what's going on here? All right, Monday morning, the 19th of December, we're moving forward in time. We got a very strong upper level high now over the Arctic Ocean. It's gone all the way north of Alaska. We still do see a little bit of ridging in the Northeast Pacific, kind of extending northward towards this anomalous upper level high height center over the Arctic Ocean. Downstream of that upper level high, we have a little bit of troughing developing here across southwestern Canada, denoted by the green coloring. We still have our west-based negative NAO with the highest heights to the east of Greenland. And then we also have the main trough axis is basically pivoted or moved off the east coast by this point. So we still have colder temperatures for sure along the east coast of the U.S. at this point. And then by Monday afternoon on the right, look at where this upper level high is now. This thing just continues to drift further and further north, basically heading towards the Arctic Circle by this point, to the North Polar area. And then you have the negative NAO, that's situated again, that west-based negative NAO, similar positioning, not really going anywhere. And then you're starting to see, more of the troughing develop here across southwestern Canada. And then the other piece of energy with that troughing is off in the North Atlantic. We do have a little piece of energy there located around Nova Scotia as well. Now, as we get to Wednesday, the 21st of December, now we're at the first day of the winter season, the winter solstice. Look at this upper level ridging now over the eastern Pacific. It's getting a little bit stronger, right? Getting a little bit stronger here. Ridge axis right off the west coast of North America, extending from south to north. We still have this upper level high, just exceptionally high heights for this latitude up here. And then further downstream, we got the trough really taking shape, colder air, really taking shape over southern Canada, south central Canada. And we still have the colder temperatures along the U.S. East Coast by Wednesday morning, the 21st of December, to usher in the winter season officially. Over here on the right is Wednesday afternoon, the 21st of December. The blocking continues over the top. Look at this. Look at this. Upper level high, and the ridging, generally again, Baffin Bay, situated to the west of Greenland. The upper level high over the Arctic, exceptionally warm up there for this time of year with this upper level high. And then downstream, we're starting to see a little bit of slow movement of these lower heights. The green coloring here starting to pivot a little bit more towards the southeast. Now you're starting to see lower heights entering portions of North Dakota by next Wednesday, the 21st of December during the afternoon. These green colors are associated with very, very cold temperatures. Just think of the atmosphere when it's more compact, the heights are lower, and that generally results in much colder, denser air. So we are going to start seeing a trough set up, and this thing means business, folks. We do still see that troughing there over Nova Scotia. By the way, this is a key factor as far as if you want an East Coast winter storm, having a closed low generally situated in this area here where this green coloring is in the vicinity of Nova Scotia. That's pretty big. And I'll get more into that in a bit. Now let's move ahead to the forecast for next Friday, the 23rd of December, 2022, and look at what happened, all right? This is where that energy was over south central Canada on Wednesday morning, Wednesday evening, and look at that, boom. It's rotated to the southeast. We have a lobe of the polar vortex, tropospheric polar vortex, now situated generally in the vicinity of Lake Huron. And we have extremely cold air that has moved in now to the eastern U.S., mid-Atlantic to New England, along the Ohio Valley. It's going to be very cold. You still see the little bit of higher heights there along the west coast of the United States. We still have an anomalous upper level high that you can barely see up here at the top portion of the image. We got the west-based negative NAO still situated up here. This blocking over the top. If I were to draw a line from this anomalous upper level high height center over the Arctic down to this feature upper level high height center over northeastern Canada, it would take on that blocking signature, okay? And so we have a very deep trough now that's firmly in place across the eastern U.S. by next Friday morning, the 23rd of December. And then here's Friday evening, the 23rd of December. Look at this thing. A lobe of the tropospheric polar vortex situated in southeast Canada. Very cold, bitterly cold temperatures in control across New England, again, the Ohio Valley down the mid-Atlantic. Next Saturday, the 24th of December, Christmas Eve. Look at where the the lobe of the polar vortex is situated. We got a very intense cold upper level low situated just to the west of Maine over eastern Canada. We have upper level ridging starting to build a little bit now along the west coast of the United States. We still see the main features of the Arctic there, blocking high. And then we also have those higher than normal heights with a negative NAO still situated in the same general position. Beneath this blocking pattern, these upper level high height centers, you have the colder air. Now that positive PNA taking shape, it's allowing the colder air to be dislodged, generally from the Arctic straight down into the eastern U.S. by this point. Now this is up to date down here, this particular text I put down here at the bottom. What do I smell with this? Like, look at the troughing here. Look at where your upper level low is. Look at where your blocking is over the top. Look at where your heights are, your higher heights now. We're getting a positive PNA. We got a negative NAO associated with this feature here. We've got a negative AO. We got a negative EPO. And we got that 50-50 upper low. Why they call it 50-50? Because this upper level cold low usually sets up at 50 degrees north latitude, 50 degrees west longitude, right in this area here. Okay? So very cold air, definitely looking more likely by the minute for the Christmas time period. Look at Christmas Day. This, by the way, I just smell a strong storm signal here. This is a very strong looking storm signal with everything I'm talking about here with these teleconnections lining up like this. You're going to have the cold, and these models are going to be all over the place as far as placement of the energy, and I'll get into that here in a moment. But let's take a look at Christmas Day itself. This is pretty cold, folks. Look at how anomalously low these heights are across the eastern U.S., the Midwest to the East Coast. And then by Christmas night, 25th of December in the evening, very similar. Look at this. Look at this. Highest heights out west, lowest heights in the east, lowest heights associated with colder, very cold temperatures. This is going to be a cold Christmas Day. Now, if there does get a storm developing off, if a storm gets developed off the East Coast, here's the thing. This trough is going to be reinforced. The cold air on the backside around that low pressure system is going to be reinforced. We're going to have very cold northerly winds all the way down the East Coast. We get a surface low pressure and a major storm system off the coast, which we think is going to happen. It's going to reinforce the northerly wind flow and those much colder temperatures. Let's move forward now. The day after Christmas, Monday the 26th of December, look at the pattern. It stays the same. Trough across the Midwest to the East Coast, both on Monday the 26th of December in the morning and in the afternoon. We still have the highest heights out west. This is definitely not a La Nina looking pattern, okay? I'm just going to be honest. This is not a La Nina looking pattern. You would normally have the trough up over the Pacific Northwest, over the Northern Plains, over Western Canada. The coldest temperatures would be up here with a La Nina pattern. And the mildest temperatures would be down here in the southeast up to the mid-Atlantic. This is not a mild pattern for the southeast and mid-Atlantic. So this goes back to the point that even though it's a La Nina winter, again, does not mean that it's going to behave the entire winter like a La Nina. This is a great case in point on this particular pattern that we're heading into. Now, I wanted to talk about this wintry precipitation and storm potential. Looking at today's midday GFS runs, okay, I did take a look at the 18Z GFS, by the way, too. Of course, we all know that it tends to have a super cold bias. So, take that with a grain of salt, right? Usually the 18Z GFS. We usually like to see the 00Z and the 12Z. 12Z has all that data ingested into it from observations, and it just tends to perform better. When you see the midday 12Z GFS run looking like this, with these very low thickness values associated with very cold temperatures working their way south, yeah, this is going to be a major cold Arctic outbreak for sure. Okay. First thing I want to look at is precipitation. Let's talk precipitation right now. I'll get back to temperature in a moment. We have a very strong Arctic front. Now, this forecast is the day's midday run from GFS. This is for next Friday, the 23rd of December in the afternoon. We see rain generally stretching from the southeast up in the mid-Atlantic, parts of southern Jersey to Long Island to Connecticut. That rain is associated, that's that moisture out ahead of the Arctic front itself. GFS at midday was showing a surface low up over southeastern Canada. It had a changeover from rain to snow further inland into Pennsylvania, New York State, Vermont, New Hampshire, as well as western Massachusetts. As this front clears the coast, there's a good chance we're going to see a transition over from rain to snow, specifically in the mid-Atlantic, as well as up into New England. With the strong Arctic front barreling east late on the 23rd of December, I'm not expecting much of impacts down here in the mid-Atlantic, okay? Because it's going to be basically a rain to quick transition to snow here by Friday evening, the 23rd of December, as the Arctic air just rushes right in. But further north, obviously, you're closer to this area of surface low pressure up here in New England. Right on the backside of that, you're going to have more energy, you're going to have more vertical lifting, more surface forcing. So yeah, you can get a pretty good amount of accumulating snows from New York State up through New Hampshire, Vermont, down to Massachusetts, and so on. So this is the first type of wintry precipitation event I'm seeing as far as the models go. Now, this is the big one though. The storm potential for 24 and 25 December, it's there. The energy is here, and that's what I'm using the red arrows to point at, is the energy. Now, got a deep trough, right? This is a great setup for a storm. We got a deep trough across the eastern U.S. We got a strong 1037 millibar high over the Dakotas. There's a constant falling of wind and colder temperatures clockwise around that high. So we got plenty of cold air in the low levels, plenty of cold air in the upper levels. We got energy just sitting here off the southeast coast. And then by Christmas, this gets into overnight, Christmas Eve, in the very early Christmas morning. Now we got an area of low pressure here off the coast. You kind of see what's going on in the 12Z midday run. This wasn't even here on the 06Z GFS run. The thing is with big storm systems, what I've noticed over the years is it tends to indicate a storm system, then that storm system kind of drops off the models, and then it comes back again, then it drops, and it comes back again. I'm not really interested specifically in the placement of this right now. We're talking a good, over 10 days out from now. So I'm just looking at the trends. All right. This is going to change. This is not going to be specifically where the storm's going to set up in either case in either of these graphics. It's just showing you that there's energy out there, and we have a very deep trough going on, and it deepens even further. There's a lot of energy with this deepening trough. We got northern stream energy. We have, southern stream energy here. Question is will these phase? Will the northern stream energy and the southern stream energy phase to where we get a monster storm off the mid-Atlantic coast, working its way up the coast a little bit towards New England? So there's a lot of questions still about this, but I just want to throw this out there. There's a lot of southern energy. Next storm, potentially the end of December before the new year. Again, a lot of southern energy. See, I'm just using the arrows here to point that out. All right, so these details specifically for these particular storm threats is going to be revealed as we get closer to the event itself. They're going to have a hard time determining where to place, stamp these low pressure systems, where to put the most concentrated energy, what's the intensity and tracks of these storms going to be like. Too early to tell, but I'm just throwing it out here. This is a great pattern. The NAO starts relaxing at this point, and we got a positive PNA. So thicknesses are higher out west. So this is just a great situation for a major snowstorm, a major winter storm. And this could be a major headache for travelers around the Christmas holiday. All right. Now let's look at the temperature anomaly forecast. We're looking at the European ensemble mean. And I start off here in the upper left to show you, this is the forecast upper left for the temperature anomalies in degrees Celsius for Friday morning, 23 December. And then the upper right, I have Saturday morning, Christmas Eve, the 24th of December. Bottom left is Christmas morning itself, 25 December. And then bottom right is the day after Christmas in the morning. This maroonish purple color indicates the greatest temperature anomalies, the coldest temperature anomalies. Generally on the 23rd, Friday, you can see the leading edge of the Arctic, the true Arctic air mass, right along the east coast of the United States. The most the coldest air is going to be situated from Missouri, Iowa, Minnesota, back to the Dakotas and Montana into Canada at this point. But over time, this slug of very cold Arctic air continues to progress in a northwest to southeast manner from the Arctic all the way down into the northern plains to the mid-Atlantic, generally the mid-Atlantic and east coast. If you look at the bottom left here, we're totally entrenched in significant temperature anomalies on the cold side by the time we get to Christmas morning, according to the European Ensemble mean. And the bottom right showing for the 26th of December that morning. So look at how cold things should be coming across the eastern U.S. The coldest period, by the way, according to this model, is from 23 to 27 December, with the heart of the coldest temperatures stretching from the northern plains to the east coast, specifically the mid-Atlantic. And then after the 27th of December, we could see some slight moderations to these temperature regimes. Here's the temperature anomaly forecast from the GFS. This is also in degrees Celsius. Similar timestamps, I use the same dates. So upper left is the temperature anomaly forecast for 23 December, upper right 24 December, bottom left 25 December, Christmas morning, and then bottom right is 26 December, day after Christmas. Similar, right? Is there much difference between the ensemble mean and the GFS ensemble forecasting system, the GEFS? Wow, this is the GEFS model, ensemble mean. So it's really amazing. Both of these ensemble systems are showing the progression of very cold Arctic air working their way towards the Midwest and eventually all the way to the East Coast, with the coldest temperature period between 23 and 27 December. That's the way it looks right now. Now let's take a look at the Teleconnections Forecast, European Ensemble on the left and the GFS Ensemble on the right. A very similar trajectory of the ensemble mean, the green line here, for the official forecast showing it. The NAO very negative here, a -3 value here on today on the 14th of December in both cases, both ensemble systems. And then you see kind of like a little recovery here, 16 to 17 December, a drop off around 18 to 19 December, then back towards closer to neutral. I'm watching this area right here when the NAO is closest to neutral. I'm watching this period 20 to 24 to 25 December, and then over here, I'm watching this for late December, 28 to 30th of December. In a similar case here, however, the GEFS on the right is showing the NAO more negative in the longer range. So a negative NAO all the way up through the end of the year on the GEFS V12. What about the AO forecast? The Arctic Oscillation Forecast showing a negative, European EPS showing a negative AO throughout, as well as the NOAA GEFS V12 negative all the way to the end of the year. The PNA forecast, this one's huge for me. All right. The European Ensemble on the left and the GFS Ensemble, the GEFS on the right. You'll notice that the European Ensemble is showing a little bit of a stronger turn to the positive for the PNA. Between 23 and 26 December, a positive PNA. It works its way slightly closer to neutral after that, but it's still slightly positive to end the month of December. And then on the right, the GFS V12 showing a positive tendency as well for PNA. Basically staying slightly positive throughout the rest of the month of December. Now, looking at EPO, Eastern Pacific Oscillation Forecast, sharply negative on the European Ensemble here on the left, all the way down to a magnitude -5, a value of -5, 16th to 17th of December here towards the end of the week. And then it slowly makes a climb and then drops off negative again and slowly makes a climb. Similar here on the right with the GEFS V12. Very similar with a very strongly negative EPO, working its way slightly more towards the neutral territory, ultimately, as we head towards the last few days of December. Moving ahead. Here is my final thoughts on tonight's video. Okay, there's like, this is, if you really like winter weather, it's just going to kind of be nice this year that we actually are feeling like the holidays in the East. I mean, there's been so many winters recently where, the month of December is just warm. Specifically, the Christmas holiday is warm as well. Here's some key points and final thoughts here to end the video tonight. Over the past 24 hours, the models have definitely shifted the core of the coldest air from the northern plains to the eastern seaboard. And this makes complete sense based on what we're seeing in this Teleconnections forecast. Negative NAO, negative AO, working our way to a positive PNA for a period of time, and then a negative EPO. It's all there. The teleconnections are telling us this. Yesterday, when I looked at the European midday run operational or deterministic model, yesterday midday, it was completely out to lunch. First of all, it was an outlier. Second of all, it had like ridiculous higher height anomalies and extremely mild temperatures across the eastern U.S. on the 23rd of December. It just didn't make sense based on the teleconnections. Specifically the PNA going positive over causing that ridge to poke up at higher heights along the west coast. It just didn't make sense to see that troughing that deep out west. Bundle up. Coldest temperature period is going to be coming up 23rd to 27 December. This is when daily temperature anomalies could be as high as 15 to 20 degrees Fahrenheit below normal across the mid-Atlantic. Yeah, the deep south, Gulf Coast, places like that, even Florida, get ready. It's going to be getting colder, and it's going to be significantly colder, not just slightly colder. There is big storm potential right around the Christmas holiday. Now, wouldn't that be amazing if there was just this similar situation to the December 2010, the December 25th to 27th, December 25th, 27th, 2010 snowstorm along the East Coast? Wouldn't that just be amazing? I mean, it's hard enough. The probability of a white Christmas seems like it's dwindling over a lot of locations. But can you imagine getting a white Christmas this year, getting one of those miracle Christmas snowstorms to places that normally don't see that climatologically? Can you imagine that? I mean, it'd almost be like a Hallmark movie. You know, watch a Hallmark movie sometimes, being a snow lover, it just gets to me because it's always snowing in those movies, right? Have you noticed that? It's always snowing. And they're obviously not living in an era that we are with global warming going on, all right, in those Hallmark movies. But anyway, big storm potential 24 to 25 December. There are additional storm chances outside of this little window I'm talking about throughout late December. I did look at some interesting research conducted by North Carolina State University, the climate office, and it's amazing. I probably should have thrown them in tonight's video. But anytime there's a negative NAO, it's like an inverse relationship to the amount of snow that you see across the mid-Atlantic. Specifically, this was for North Carolina stations. But whenever there's a negative NAO, it's an inverse relationship. So that means a negative NAO yields above normal snowfall across the mid-Atlantic, and a positive NAO yields below normal snowfall. So it's amazing the power that the NAO presents itself as far as the upper level pattern and how these troughs and ridges set up between a negative NAO and a positive NAO. It's just really crazy. Anyway, it's too early for specifics on that big storm around Christmas. We'll continue to watch that. Again, there's that correlation bullet I put in there between the negative NAO and mid-Atlantic snowfall. Additionally, what we're looking at over that specific time period around Christmas, we have a 50-50 low. We have a negative NAO still there, the blocking over the top. We have the deep eastern trough. Whenever you get the deep eastern trough, I want to point this out. Whenever you get the big dip in the jet stream, you get the big eastern trough. You get these big troughs like this, right? Right, like this, right? Generally along the leading edge of these Arctic fronts, there's a huge temperature difference from ahead of the front, very milder air over the water of the Western Atlantic, and behind the front where there's just very cold air. Significant temperature drops over short time periods. So there's going to be a lot of energy involved with this change from to a very cold, bitterly cold Arctic air mass is what I'm getting at here. All right. Bottom line, we're expecting a lot of model volatility to continue from run to run as far as hammering out details for specific storm tracks and intensities. Definitely, these dates could shift along with the storm tracks. Look. I'm only showing you this because I feel like these are some winter weather opportunities here. Specifically when that Arctic front blows through, changing the rain to snow along the East Coast. And then, 24, 25 December looks good for a storm to form. I'm just showing you where this energy is. That's all I'm doing here tonight. There's no way this is going to turn out exactly what this map looks like as far as the placement of the energy and the potential storms. Just not going to, we're talking beyond 10 days here in time. Okay. So as we get closer, these models are going to eventually latch onto a solution. There's going to be a lot of back and forths going on with the models. But one thing's for sure with high confidence that we can say, the ensemble models are locked in for upper level height rises and some ridging in the western US. That's associated with that negative EPO and positive PNA, and then that troughing over the eastern US in association with a negative NAO and negative AO pattern. Let's face it, it's taken a while for the atmosphere to respond to that blocking over Greenland, that negative NAO in the Baffin Bay. It's taken a while. It's taken a while for the atmosphere to respond. So there's a delayed reaction here between the overlying atmosphere and what actually happens with the chain of events that occur with a negative NAO. It's not like magic. Like you flip on a switch, right, when you go to a room to turn the light on, or you turn it off when you leave the room. The atmosphere sometimes doesn't work that quickly and respond that spontaneously to specific upper air features and patterns. All right, that wraps things up tonight, everybody. I hope you enjoyed the video. We are getting closer and closer to this man coming up here in the upper right-hand corner, Santa Claus. 24 December, Christmas Eve, and Santa, hopefully he's got extra blanket this year to stay warm in that sleigh because it's going to be pretty cold across the eastern U.S. All right, that's all I've got for now, everybody. And I hope you enjoy and learn something every time you watch these videos. Until next time, everybody, take care and God bless.